નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Good morning, students. Today, in standard 10th, subject mathematics, we are going to learn chapter 11, constructions. Today, in exercise 11.2, question number 3, we have to draw a circle with the center O and the radius 3 centimeter. Then we have to take 2 points P and Q on one of its extended diameters, and each point P and Q at a distance of 7 centimeter from the center. Then we have to draw the tangents to the circle from these 2 points P and Q. So to construct, draw the circle, take 2 points on the diameter such that the distance is 7 centimeter from center O. That is OP equal to OQ is equal to 7 centimeter. Then draw the tangents from point P and Q. So to draw the tangents, first of all we have to draw the circle. We must have the circle with the center O and the radius 3 centimeter. So here, taking center and the radius 3 centimeter, let's draw the circle. Circle with center O and the radius 3 centimeter. We have to draw the circle. So here with center O, we have to complete circle with radius 3 centimeter. So now it is the circle with center O and the radius center O and the radius 3 centimeter. Now we have to draw the diameter and extend the diameter and get the points P and Q at a distance of 7 centimeter from point O. So let us have So now this is point P and this is point Q at a distance of 7 centimeter from center on diameter PQ. Here P diameter passing through the center of the circle. Now our question is to draw. Now we have to draw. This is given condition. We have to draw tangents from point P to the circle and from point Q also tangents we have to draw to the circle. So first of all, let us draw tangents from point P. So to draw the tangent from point P, first of all we have to get the midpoint of OP. So how to get the midpoint? By getting midpoint. So to get the midpoint, we have to draw the arcs, taking P as a center in both the semicircle. Then taking center of the circle also we have to draw the arcs. So now here we get the point midpoint M of PO. M is the midpoint of, this is M, that is a midpoint of O, midpoint of PO. Now taking this point as a center and the radius is equal to OM or PM, we can go get the circle. Okay, so taking this point, we got the circle. Now join P here. This will intersect the circle at point A and at point B. Then join PA and PB. So these are the tangents from point P. Similarly, we have to draw tangents from point Q in the same manner. That is, first of all, we have to go for the perpendicular bisector or get the midpoint of OQ. That is perpendicular bisector of OQ. So let us get the midpoint perpendicular bisector. That is by, to get this midpoint, we have to draw arcs in both the semiplane. Then taking that point, midpoint, here taking this point as a center, we have to draw circle. So here this point is N, is a midpoint of OQ. So taking this midpoint N as a center, and the radius is equal to distance of ON or NQ. We can draw the circle which intersects the given circle at 2 points C and D. So we can have this point. Now you can see these two are circles. They meet at a point, center here. This is O, is a center. So now this intersects at 2 points C and D. So this circle with center N intersects the given circle with center O at C and D. So here join CQ and DQ are the tangents to the circle from point Q. So these are our required tangents. These are our required tangents. Okay, so let us write the steps of construction. So first of all, what we have done here, draw circle with center O and the radius 3 centimeter, and take P and Q on diameter such that the distance from the center, that is OP, is equal to OQ is equal to 7 centimeter. After this, we have to draw the tangents now. So here get midpoint or take midpoint or take midpoint of OP and OQ as M and N respectively. After getting the midpoint, draw circles. Draw circle with center M and the radius MP, and circle with the center N and the radius NQ. which intersect the circle with center O and the radius 3 centimeter at A and B and C and D respectively. So here this circle intersects at A and B, and here this circle intersects at C and D. Join PA and PB are the tangents to the circle at center O and the radius 3 centimeter, and join QC and QD, and these are the tangents to the circle with center O and the radius 3 centimeter. So these are the required tangents. So how can you say that they are tangents? So justification that they are the tangents. First of all, we will go for the tangents with the here from point P. So here, as we know, what we have done here we have done, first of all, here join OA. You just join OA. So when we join OA, this forms a right angle. Join OA. So what happens here, when we join OA, which is radius, actually here it is radius, this OA is radius, and here when we draw this radius, OA becomes perpendicular to PA. It becomes perpendicular to PA. Why it is perpendicular to PA? That is here angle in semicircle. Angle in semicircle. You can see in this here OP is a diameter, so it is a semicircle, so it is a right angle. So now when radius OA is perpendicular to this, therefore here we say here OAP is equal to 90 degree, we say. Is it clear? That is perpendicular and also it is radius, therefore PA is a tangent. Therefore PA is a tangent to the circle. Any line segment from a point P in the exterior is perpendicular to radius, then it is a tangent to the circle. Similarly, PB is a tangent to the circle. Same way, let us go for here. First of all, join OC. So let us join OC. You see here, similarly this also we can say here is also tangent because it forms a right angle. Now it is said for tangent from point C, to get the tangents from point C, this is right angle. Same way from point Q to D, this also forms right angle. So QC and QD are tangents. So here, which is radius, and here angle OAP is equal to 90. Therefore OAP not, but here OC we have drawn. So here OCQ is 90, and therefore we can say OC is perpendicular to CQ. OC is perpendicular to CQ. Here angle in semicircle. Angle in semicircle, right angles, and therefore we can say CQ is a tangent, as it is perpendicular and also that forms a right angle to the radius at a point of contact C, and therefore CQ is a tangent to the circle. Similarly, DQ is also a tangent to the circle. So this is the justification. So we can get this way tangents to the circle, and we can justify that. How can you say that they are tangents? Now next question. Now exercise 11.2 question number 4. Here draw a pair of tangents to the circle with the center O and the radius 5 centimeter. But here we have not given the point outside the circle, but we have to draw from outside the circle tangents to the circle, but these tangents meet at a point outside the circle, forms an angle of 60 degree. That is, they are inclined to each other at a 60 degree angle. So construct the circle first of all, and then draw the tangents which forms 60 degree angle to each other. So first of all, we have to draw the circle with center O and the radius 5 centimeter. Circle with the center O and the radius 5 centimeter. We have to draw the circle first of all. So circle with radius 5 centimeter. Here is a circle with center O and the radius 5 centimeter. This is the center O and the radius 5 centimeter. Now we have to draw tangents which form 60 degree. Therefore, we have to form 120 degree. That is supplementary of 60. That is 120. So first of all, draw the radius here OA, then make 120 degree and get point B on the circle. So draw 120 degree at O. So to draw 120 degree, we have to draw arc Now taking this point as a center, 60 degree and then 120 degree. Taking this point as a center, this arc, and then taking this point as a center. So still we need an arc here. Taking this point as a center arc. So here 60 and then 60, 120 degree. So now we will get a point on draw OB such that OAB is equal to 120. So here we have constructed OAB is equal to 120. Now we have to go get the point here P such that this is a right angle. When we draw the line segment and this is a radius OA, and if we draw perpendicular to that, then it is a tangent. Same way here also perpendicular. So they meet at a point and they must form 60 degree angle. So to construct here 90 degree at A and B, we have to take A as a center. Here this 90 degree we have to draw this side. So first of all we have to draw the arc for this. First of all 60 degree and then 120. Then here from this point and here from this point, from 60 and 120. So you will get 90 degree here. So now this is 90 degree. This forms a right angle with the radius. Okay. Similarly, we have to draw again 90 degree at this point. So for this, taking B as a center, and we have to draw the arc. Now taking this point as a center, and this is 60 and 120. We have to draw the arcs here. So now how to construct 90 degree, you know. Then taking this point, here also we can draw perpendicular to radius. And here they meet at point P, and so this is 60 degree, because this is right angle, this is right angle, this is 120, so this is 60 degree. So PA and PB are the required tangents. So let us write the steps how we have constructed this. So here, first of all, steps of construction. First step, given condition, circle with center O and the radius 5 cm is drawn. Okay. Then take points A and B on the circle. We have to get these points on the circle such that this angle formed between them, angle formed between AOB is equal to 120 degree. Why this angle must be 120 degree? We want 60 degree. They are supplementary. Here 90 plus 90. So we want 60 degree here. So the total 120 plus 69, 180, and this also 180. So total sum of all the angles of the quadrilateral 360. So as it is given here, we are constructing 90 only to get the tangents. So here 60 required. That means we have to construct here 120. Okay. After this, after getting this point, join here. Join OA and OB. After joining OA and OB, we have to draw per 90 degree angle, that is draw here perpendicular by forming 90 degree angle, that is draw OA perpendicular to AP and OB perpendicular to BP, which intersect at, so here it intersect at P. Here thus OA and PA and PB are the required tangents. So now these are required tangents forming 60 degree here. So justification for this, how can you say that these angles are this angle here 60 degree? So these P and PB are the required tangents such that here angle formed is APB is equal to 60. So how can you say that it is 60? Is in quadrilateral OAPB, sum of the angles, that is angle AOB plus angle OAP plus angle OBP plus angle APB is equal to 360 as sum of the measures of all the four angles of the quadrilateral 360. Here this is we have constructed 120. This is we have constructed 90 degree so that it is perpendicular to line segment with the radius. And this our requirement APB must be 60 degree. So whether it is 60 or not. So here total sum is 180 plus this is 300 plus angle APB is equal to 360 and therefore angle APB is equal to 360 minus 300 and that is equal to 60 degree. So this to 60 degree at the same time PA is perpendicular to OA radius and PB is perpendicular to OB radius and therefore PA and PB are required tangents. These are required tangents forming 60 degree to each other. So this way we can construct tangents to the circle. Thank you for joining us.